Okay, so this course requires some mathematical representation, so usage of the graphs and formulas, etc. So that I started with explaining appendix of case and fair actually. Okay, so appendix using graphs. Okay, and I suggest you to work on those. So this is high school elements actually, but you may forget it. Just work on those because you may need it. Okay, so we can group the graphs into two or more. So let's start with graphs with one variable. Okay, graphs with one variable. So you can represent those either by using bar graph. Okay, so if you use Excel, you are familiar with those, or pie chart. Okay, an example for this is market share of cars in the world. Okay, so if you have such data, okay, and if you have such data, how we are going to represent this? Okay, so you have big three. So these are the cars of US actually. Okay, Japanese firms, Korean firms. Okay, and you have European firms. Okay, so big three, the percentage of the, so these are the shares. Okay, 46.9% here, 35.3% here, 9% here, 8.8% here. Okay, so if you're gonna use a bar graph, how are you gonna do it? Okay, so firms are here and shares are here. Okay, so we have big three. Let's draw a bar for big three. Okay, and then this is 46.9%. You have Japanese firms. So this is Japanese firms. It is 35.3%. And we have Korean firms. Okay, and it is 9%. And we have European firms. Okay, this is 8.8%. Okay, so this is for the bar graph. For the pie chart, you will have something like this. Okay, and then a pie, and then we are gonna, so from the beginning, okay, from the beginning we have a share of 46.9% for big three. Okay, and then we have Japanese firms, 35.3% Japanese firms, and we have Korean firms and European firms, 9% and 8.8%. So this is an example for the pie chart. Okay, now graphs with two variables. Actually, this is what we are gonna use in this class mostly too. Okay, when we are gonna draw demand and supply graphs, for both of them, you are gonna have price in one dimension, quantity demanded or quantity supplied in the other dimension. We often use graphs to show relationship between two variables. Suppose you want to draw a graph for the following data. Okay, so we have, suppose, the following data. Okay, so here is the price and here is the quantity. Okay, so price is $1 per pizza, and quantity is pizza per week. Okay, so if the price is 15, quantity demanded is 50. If the price is 14, quantity demanded is 55. If the price is 13, quantity demanded is 60. If the price is 12, quantity demanded is 65. If the price is 11, quantity demanded is 70. Okay, so actually you are gonna have a pair of points for each pair for the price and quantity, and then you are gonna combine them. Okay, so this is quantity demanded in one dimension, this is price. Don't forget to write the axis names. Okay, so if the price is 15, quantity demanded is 50. If the price is 14, 55. If it is 13, 60. If it is 12, 65. If it is 11, it is 70. Okay, and then you are gonna combine those points. Okay, so you're gonna combine those top points. Actually, this is a demand curve. Okay, graph showing the relationship between price and quantity demanded at each price. Okay, so from here what you can do is you can find, so from this direction you can show the relationship between price and quantity, right? So it's a negative relationship. You can also find the slope of lines. Okay, so the slope tells us how much the variable we are measuring on the y-axis changes as the variable we are measuring on the x-axis changes. Okay, so the slope tells us how much the variable we are measuring on the y-axis changes as the variable we are measuring on the x-axis changes. Okay, so we are using delta as the change in one variable, Okay, so the slope is delta y divided by delta x. Okay, so in the y-axis we have price of pizza. Okay, in the x-axis we have quantity of pizza. Okay, so you can take any 2 points in here, let's say from A to B, in order to calculate the slope, how the variable on the y-axis changes as the variable on the x-axis changes. Okay, so from A to B, so price change from 14 to 13. Okay, 13 minus 14 divided by 60 minus 55. This is minus 1 over 5. Okay, so the slope is this. Okay, the larger the slope, the steeper the line will be. Okay, or the smaller the slope, the flatter the line will be. Okay, so as I told you, so you can tell positive or negative relationship between two variables by looking at the line relationships. Okay, so the graphs show the relationship between two variables. Negative means as the one variable increases in value, the other variable decreases in value, as in here, right? So as x variable increases, price decreases, or price decreases, the x variable increases. Okay, as the one variable increases, in value, the other variable decreases in value. Okay, so this is what we showed in the earlier graph. So if there's a positive relationship between two variables increase or decrease together. Okay, when total income received by households increases, the level of consumption increases, or the income you have increases, consumption you made increases. Okay, so this is about the relationships. Okay, and then do we need to have the graphs always straight lines? No. So you can have nonlinear curves. We are gonna do 201 actually in the upper courses for the microeconomics. Okay, so firms can have convex cost. Okay, so this is the input, let's say x1. So this is the cost of production. Okay, so this is convex. Nonlinear graphs are there too. Nonlinear graphs, all graphs, all of the representations shouldn't be linear. Okay, so how do you find the slope of a nonlinear curve? Okay, so you take at a particular point, you draw a tangent at that point, and you find the slope of that tangent line. Okay, the slope of a nonlinear curve. Okay, at a particular point, we must measure the slope of the tangent line to the curve at that point. Okay, so you're gonna find the slope at here. Okay, so yeah, that's it for the graphs. We're gonna draw some graph examples on Friday when we meet, and tomorrow I will upload the first part in the book. Okay.